Hello and welcome to Uncle Matt's Online Academy. Today we have relative density. So we are going to learn the meaning of relative density. We study the meaning of relative density and we also learn how to determine relative density. Then we will learn how to solve calculations involving relative density. Now, meaning when we are talking about relative density, we are trying to express the density of a substance in relative to the density of water. That is, relative density compares the density of different substances with the density of water. Water is taken as the standard substance. So, we try to compare the substance and that of water. Is the density of the substance greater than that of water, or is it smaller than that of water? That is what we do in relative density. Because the density of water is just 1000 kilogram per meter cube, we take it as a standard. So to see whether the density of a substance is high, we check whether it is more than 1000. And to check whether it is low, we check whether it is less than 1000. 1000, which is the density of water, is taken as the benchmark for comparing other substances or the density of other substances. That is what we do in relative density. So we define relative density RD, as density of the substance all over the density of water, all over density of water. Now, since we know that the density of water is 1000, we can also say that the relative density of a substance is equal to density of the substance all over 1000, because this 1000 represents the density of water. So these are the ways we express relative density of different substances. We can also determine the relative density of substances by using these formulas. Relative density, we can also compare the weight of the substance with the weight of equal volume of water. Whatever it gives us is still the relative density of the substance. What I mean by this is this: if we don't know the density of the substance, but we can get the weight of it, maybe we have a weighing balance to get the weight of the substance. What we do is that we get the weight of the substance and get equal volume of water. Find the volume of that same equal volume of water and then compare the two weights. That will still give us the relative density of the substance. Therefore, relative density of a substance can also be expressed as weight of a substance, weight of the substance all over weight of equal volume of water. This equal volume is very important that you put it. If you say weight of water, you are not getting it. You must say weight of equal volume equal volume of water. If what you have is the mass of the substance instead of the weight, we can also use the mass to get the relative density, and therefore we can also say that relative density is equal to mass of the substance over mass of equal volume of water equal volume of water. Now please note this, there is no unit for relative density. Why? We are comparing the same things. The density of the substance is measured in kilogram per meter cube, while the density of water is also in kilogram per meter cube. Therefore, the units will cancel and we don't have a unit for relative density. So these are different ways we can express the relative density of a substance. One, we can express it in terms of the ratios of the density of the substance and the density of water, or the ratio of density of the substance and 1000, or the ratio of weight of the substance and weight of equal volume of water, or the ratio of mass of the substance over mass of equal volume of water. Now we look at the ways we can determine relative density. How can we determine or measure the relative density in the laboratory? To get the relative density of a substance, we use an apparatus called the relative density bottle. We've mentioned about relative density bottle in the previous lessons on density. Relative density bottle. This relative density bottle it looks like this. What we do is that we get a weighing balance, check the weight of the relative density bottle when it is empty, then we can get or we can record the weight as W1. Now we fill this relative density bottle, then we fill it with the substance we want to get its relative density. Maybe when we fill it with the substance, then maybe the weight becomes W2. Then we remove the substance we put inside the relative density bottle, empty it again, and then put water, fill it with water. Maybe when we fill it with water and weigh it, maybe the weight becomes W3. Now to get the relative density of the substance, we now say that the relative density of the substance is equal to weight of the substance all over weight of equal volume of water. Now we know that we have equal volume of water because we are using the same apparatus. We fill this with the substance and also filled it with water. It's still the same volume of this relative density bottle that we are measuring. So there is no need to determine the volume again. Just fill the relative density bottle with the substance and also fill it with water. Now, to get the weight of the substance, we subtract the weight of the empty relative density bottle from the weight of the relative density bottle and the weight of the substance. And to get the density of water, we subtract the weight of the empty relative density bottle from the weight of the relative density bottle and that of water. So to get the weight of the substance, we say W2, which is the weight of the bottle and the weight of the substance, minus W1, which is the weight of the bottle alone. And to get the weight of water, we say W3 minus W1. So relative density now is equal to W2 minus W1 over W3 minus W1. So this is how to get the relative density of a substance. How to determine the relative density of the substance. For example, if we are told that the density of a substance is 2000 kilogram per meter cube, and we are asked to calculate the relative density of this substance. Calculate its relative density. In brackets, they may give us that the density of water will be given that the density of water is equal to 1000 kilogram per meter cube. Now, this is very simple to do. Solution. We say that relative density is equal to density of a substance all over density of water now, which is equal to relative density of the substance is equal to 2000, which is what is given to us, over 1000, which is the density of water also. So we are going to have that RD is equal to 2. Answer. We don't have any units for it, so the answer is just 2. Example 2. What if we are told that the relative density or the density of a substance is 4000 kilogram per meter cube? Find its relative density. We are not given the density of water. Without the density of water, we know that the relative density can be expressed as density of the substance all over 1000, now which is equal to 4000 over 1000. So we have 4 as the answer. So without the density of water, we can still calculate the relative density. If they give us the density of water, fine, we use whatever they give us as the density of water. Now please note that in some cases they will give us density of water as maybe something greater than 1000 or something less than 1000. Once you are given the density of water, take that density given to you. Don't say that the density of water is 1000. You must use the density of water that is given to you. If they give you 1000, fine. If they give you anything above 1000, you use it. If they give you the one that is less than 1000, you also use it. But in a case where you are not given the density of water at all, you divide by 1000 and get your relative density. Example 3. Example 3. An empty relative density bottle weighs 200 kilogram 200 gram 200 gram and weighs 300 gram when filled with a certain substance. Determine its relative density. Determine its relative density, or determine the relative density of the substance. Determine the relative density of the substance. Determine the relative density of the substance if it weighs 400 gram when filled with water. Okay, now solution. We know that relative density is equal to weight of the substance over weight of equal volume of water, now which is equal to weight of the substance in this case is equal to weight of the substance is equal to this weight of the substance. An empty relative density bottle weighs this, so, and weighs 300 when filled with a certain substance. That is, this 300 is the weight of the relative density bottle and the weight of the substance. So the weight of the substance is 300 minus 200, and that of water is 400 minus 200. Okay, so is equal to 300 minus 200, and that of water is 400 minus 200. Now you must make sure that the same thing is here, because two of them are minusing the relative density bottle. So this one will subtract the relative density of the bottle, and the down one will also subtract the relative density of the bottle. So we are now going to have that the RD is equal to 300 minus 200 is 100 over 400 minus 200 is 200. So the RD is equal to 0.5. No units. So this is how to determine the relative density. Sometimes they may record the weight that it weighs maybe 200 Newton, that is weight. You also use that one to calculate the relative density, whether you are given the weight, the mass of the substance. You can use any of them to get the relative density. Just compare with equal volume of water. So this is it about relative density, and I hope the lesson is very clear. Thank you.